All right. So today we are doing SQL queries. Excuse me. Um, I know we've seen a little bit of queries, but we're gonna do a proper dive in now. Um, we're actually gonna cover a whole lot of ground today. We're gonna start out with the select query that we know and love to get information from tables. We're going to see that Postgres actually gives us a lot of functions, usually called aggregate functions like count greater than or less than. So I could get, say, the average value for the age of all the students in the students table. We're going to see how to filter results with the where clause. We're going to see how, especially as the queries start to get more complex and we use um, these aggregate functions, we can do group by, just sort of roll up results. And then finally, we're going to do join, which is really a topic all of its own, which is how we actually get data from multiple tables simultaneously using our primary and foreign keys. So, for example, all students in the math class. And we'll see that when we get there. And join is a bit of a deep topic. There's different kinds of joins, and we'll talk about that. Um, And then we'll also see multiple joins. And we'll also talk about, and this is sort of related to joins, using the as clause to give our own column or variable names, essentially. There's a couple other things, but this sort of covers the gamut of it. So it should be good. Do folks have any questions before we dive on in? Cool. And the plan today is, let me go ahead and set up my tiling here. Um, Part one of the lecture is good. That goes over some valuable stuff. To make sure I hit the most critical stuff first, I'm going to start with queries and joins, but if we have time, we'll cover this, and it is worth going back to. Um, I'm going to have this up on the side because we're just going to be writing out some of these queries as we go. And I think having the two side by side will be useful. Also, we'll walk through this in a minute. Oops, excuse me. But since we're doing queries today, we obviously need some data. And there is a car shop SQL file that creates a bunch of tables and a bunch of CSV tables with data. And so I'm going to walk through this and also show a nice technique we can use to get this visualized in DB diagrams. Um, so let me make an empty raw SQL diagram for this car shop. And let's walk through this and let me show you how one way to throw a whole schema into draw SQL in one go. And that's how we'll kind of look through our data first before we start writing queries. Sound good? Cool. So for the car shop, we've got one moment. Thank you, folks. Um, so walking through this, let's just start looking at our data. We've got cars with ID, make, model, year, kind of all the things we would expect. Drivers of cars, employees at the car shop, license plates, and note here this car ID, right? So this is a foreign key. We can make a reasonable guess. Services that different cars have had, or rather different services that we can get. And then here's services that cars have had. And anyone remember what the name, anyone want to guess at like what kind of relationship this represents here? Is it like a one-to-one relationship we're looking at between, say, our car
Looks like a
table and
many to
service?
many to me. So,
Yeah, exactly. We see here there's a sort of a generic primary key ID, but then there's the ID of the service and the ID of the car that got the service. So we've got two foreign keys here, and that's a many-to-many relationship, and that's using the join table technique. Um, I'm not going to go through the SQL in full on this. I think we've seen a good amount of this, and also I'm going to load it into Draw SQL in just a sec. Um, but we have what we would expect here for building this database, for creating these tables, and copying each of the bits of data in. As folks pointed out yesterday, we do have to think about the order of things. And Kenny, I think you were saying how like maybe we want, the join tables or tables with foreign keys to be last. And indeed, that's what we're doing here, where this car service table, because it depends on the services table and the car table, we're gonna create the table last so that the other tables exist and then import the CSV data last. So I've already gone ahead and built this database, and we have all of our different tables. I built it just by running the /i command to execute all the SQL in pSQL. And just as a sanity check, I'll do select star from cars to make sure it's probably singular that I've got data in there. Let me show you guys a really useful technique that we haven't seen yet that dumps out the whole schema of a database once it's created. So whether I've created my database with one single SQL file or an SQL file and a bunch of modifications that I did with pSQL or other files, it sure would be useful to be able to spit out, you know, the SQL code for all the current tables in my database as a file and sort of a record. And we can indeed do this with a command called Postgres dump. And I was playing around with this a bit earlier. And so this Postgres dump command, I give it the name of the database I want to dump. And it actually just spits right out to the console a whole bunch of SQL. A lot of this is alter table, there's select statements, there's other things going on. But what I want to do is send the output of that command into a new file. And the term for this is, I believe it's like a data definition library, but it's still an SQL file. So we'll put an SQL extension at the end of it. And now if I look here, um, there's a whole, this is, as you can see, Postgres generated a lot of information here. It's a database dump. There's a lot of Postgres settings here, text encoding. There's probably something about time zone in here, some other things that are a little more advanced. But then we see here the different tables, right? And there's this public that's added. I'm not sure why, to be honest. I'd have to look it up, but it's a little sort of outside the scope of what we need to worry about. And we can see here there's extra stuff, but we can see, in fact, all of our tables and all the sequences for those tables for things like primary keys or unique constraints generated. And so this is actually kind of a cool way to see like every single thing that Postgres is doing when we run our SQL. But the nice thing about this, and I could create a database in Postgres with pSQL using this if I wanted to. But what I'm going to do is I'm going to do in draw SQL file import, and we're going to import from a DDL file. It does need to have the .SQL file extension on it. I forgot that earlier, and that threw me for a loop. And we'll give it a minute. But what this is going to do is now I'm going to get our whole schema, and I know it's accurate because Postgres spat it out, and we're going to have it good to go here in draw SQL. And let's see it. One statement was unsupported. Yeah, I don't really know what that means. As long as this works, I think we're good. And this is kind of nice, right? Because now um, our job is to make the computer do the work for us
Wait,
at the end
I'm
of the day
sorry.
as software engineers.
I'm sorry. Could you recap how you did that? I just wasn't sure where you were going with that when you were talking about as far as
Oh,
like, putting the table. Just a real
yeah,
quick re
totally. It's super simple. When we install Postgres, a bunch of command line utilities get installed. There's the create DB that will create a database, right? That, this I could connect to pSQL and run create database foo, or drop database foo. Um, but that's a command line utility that's a helper. So it's using pSQL. And another command line utility is pg dump, and that will spit out all the SQL for building the schema for a database of our choice. If I run that command, it just outputs it to the terminal, which is not very useful. So this next bit is a Linux thing. That little arrow, it's sort of like a pipe, and it says send the output of this command to this other thing. And I could have another program here, but in this case, what I want is I'm sending it to a new file. So Linux will take the output from that command. It will create a file with this name, and it will pipe or send the output from that in here.
Okay.
Yeah. This is not strictly necessary for the assessment or anything like that. It is good to see, and it is nice because then you can just import that here into Draw SQL.
Okay, so you just so once you create that file, you just straight imported it into Draw SQL
Yeah,
and it pretty much
exactly.
did something with that data, with that data. Okay.
Exactly. And that's because this file is literally all the SQL commands Postgres runs to create our database. Like we can see when I create a table, there's some stuff happening under the hood, right? Say with we might like in our code, we might have, let's see, where's the car table? It is hiding from me. There we go. Create table car, ID, serial primary key. Well, what Postgres is really doing is for the car, and let's find public car. And this is a little more under the hood than we need to be going, to be totally honest. But just to give us a sense of what the heck this file is, Postgres takes that SQL, but it's actually doing more stuff. This sort of dot public we don't have to worry about, but note that like it creates a sequence for the ID, and that's how it builds the primary key. So this is all the SQL needed to create exactly the database that we have, exactly the way that Postgres does it.
Okay, so you imported the car shop underscore ddl.sql file into the into Draw SQL.
Yeah, and you can name it whatever you want as long as it has a .sql file extension. These files are often called like data definition um, libraries is maybe what the L stands for. Like if I go here to import from a Postgres DDL file, I literally clicked on that and then just chose the file.
Okay, I'm
But
good.
I could also use this with pSQL to rebuild or build this whole database exactly the way it was. Not sure if the data is there, but all the tables in the schema would be correct. Does that help?
Yes, I'm good. Yeah, I was just kind of curious where you were
Awesome.
going, and I just needed a quick recap.
Yeah, totally. And really, the goal of that was just like I wanted a quick and easy way to see our data schema because rather than like looking through SQL files and the car SQL file, now we can look at this and we can really see all the tables and their relationships, right? And so we see that we've got an employees table. Um, there's can everyone read this okay, by the way, in DrawSQL? Cool. There's a foreign key department ID, right, that connects to the department table. Um, and in fact, let's pull up as I walk through this, we can kind of see this in the SQL. So we've got our department. We can see our department data here, right? That's pretty simple from the raw data. Um, and it's a little cramped here. So let me just get rid of this sidebar. So we can see, here's the SQL for the department table, but I think this visualization is useful. Car gets serviced, and this is our many-to-many relationship with our join table with service ID and car ID, the kinds of services a car can have, right? Um, the cars themselves. License plates are stored in a separate table, mainly for learning purposes. And then finally, we've got driver information, right? And note that the car has this foreign key for the driver ID over here so that we can connect drivers to cars. So I just wanted to give an overview of the data we're going to be working with before I start writing queries against it. And do folks have any questions about this schema and this data before we start writing some queries and SQL and stuff? Okay. All right, let's dive on it. So I'm just going to kind of pull this up here, um, so we can kind of have this as this on the side as we do things. And let me go ahead and close out some of these that we're not going to need. And I think what I'm going to do is very quickly make a new file. We'll call it touch. And I'll bump the font size up here a bit. And we're going to start building stuff. Um, and I will have pSQL open here because it's going to be really useful to have both, right? And as a friendly reminder, I'm just going to pull up a list of all of our tables. So with the query, the query we're most used to is select. And this is how you get rows from a table. And when I do select, I can say what columns I want. Like on the command line, the star or wildcard operator means everything. So I'm saying, give me all the columns from and all the rows from the car table, right? And so what select will do is it will get all the rows, and for each row, give us back the columns that we asked for. And so maybe I only want the make and the model. I don't need every single column. I still get all the rows, but I'm getting just the columns that I want. Um, this is great, but it would be nice if we could do a bit more, right? And that's where our next best friend comes in when we're using the select query. I'm sure you guys have seen this, even though we haven't explicitly talked about it yet. We'll add a clause to that query called the where clause. And you can write it all in one line. It's kind of nice to put the different clauses on separate lines, and you start getting used to it. But it's really dealer's choice. And so now I'm saying only give me the row from this table where the ID equals 3, right? And my where clause can be anything I want. It doesn't just have to be the ID column. It could be where make equals, let's see here, what's when there's more than one. But looks like they all only have one. Where make equals Toyota. And then I get the column where the make of the car equals Toyota. And let's see if we can find something where we will get multiple rows back. Um, let's see. Here we go. We've got two blue cars. So, if I did select star, and instead of star, let's maybe do ID, make, model, where the color is blue. Well, this query, it starts by getting all the rows and it filters them for the only the rows that match this where clause, right? So we're only going to get the rows where the color is blue. And then we're saying, hey, I only need these columns from those rows. And I just want to check in how folks are feeling about the fundamentals of select with getting different columns or all of them and using the where clause to filter the rows that we're getting. Um, how are we feeling? Do folks have questions? Are there any examples or things people are curious about that we might want to try out?
If you were running this, like in the terminal, like outside of PostgreSQL, would it just be as simple as like PSQL slash the name of the database, or sorry, PSQL, the name of the database, less than sign, and then the name of the database dot SQL or queries dot SQL file, kind of like when you import the data.
Uh, Short answer is yes. I'm terrible at remembering stuff like this, but however you run an SQL file with pSQL from the command line
Yeah.
is how you would do it.
Okay, so
Does
it's
anyone remember how to do that actually? How do I run if I want to run queries.sql from the command line? How do I do that?
so PSQL, then space, and the name of the database, and then the less
And
than sign, the
why
less
the
than. I think, and then the name of the SQL file. So I guess in this case, queries.sql.
what's the less than sign for?
Um, well, I mean, I'm just reading off the command that you use, like for example, when you're creating tables.
Oh,
I just
oh,
don't know
I
if it's,
see. I see.
I just know if it's
I
on
see
this.
what you're saying.
Yeah.
Yeah, I think yeah, you're totally right.
Okay.
I see what's going on. I got
Okay.
a little confused
Yeah.
because I was thinking of like Linux, but it's actually doing the same thing. They're kind of stealing from the command line Linux syntax. The less than sign is sort of like a pipe. They're saying, hey, this query, do it against this database. I think is what whoever came up with that, that was what was going on in their head. Thank you, Jason. Yeah, so that's exactly how we would run it. And I can do this stuff from pSQL as well. And to be honest, pSQL is great for doing this for simple things, right? I do want to point out one gotcha, by the way. We'll talk about how to deal with case sensitivity later, but by default, everything is going to be case sensitive. So in fact, um, it's I think it's a bad idea to store almost anything uppercase in a database because it makes querying harder. You can always, when you get the data out, like uppercase the first letter of a word. You know what I mean? Unless it's a sentence. When you're creating your own data, my recommendation is, again, unless it's like a full on English sentence, lowercase all the text going into the database so you don't have to think about this. So we'll see how to handle it later.
I got one more question, then I'll be then
Yeah.
out. Oh, okay.
Yeah.
So essentially, the equivalent to what you're running in the database is the slash I dot slash dot slash queries dot SQL. It's kind of like the equivalent when you're
Yeah.
running.
Exactly.
Okay.
Exactly.
But you have to, but yeah,
Uh,
but in order to run it like that, you have to make sure you're in the correct place in the terminal and into the correct directory.
exactly. Exactly. Like when I started pSQL, I made sure that I was in the same directory as queries so I could do that.
Okay.
And let me connect back to CarShop and do a quick sanity check that I'm in the right spot. Yeah, exactly. You hit the nail on the head.
Okay.
Yeah, and I like working in pSQL, so that's why I do the slash I because a lot of the time I will just this it's great to like test out your queries by building them in pSQL because I can do like select, make from car. I don't you don't need to capitalize stuff. where, model equals Camry. But so we have a record of what I'm writing. I'm putting it here in the file. I do think this is a good flow though, because you can edit a file, you can see what you have, you can experiment in here, but try to get stuff into a file. You don't want like important stuff not living in a file because then you'll inevitably forget it, or it's harder to duplicate. Cool. So we're gonna see more stuff going on with the where clause in a minute. Um, but let's start looking at some of these math operators that are hiding here in the curriculum and see what's going on. And as you can see, there's a lot of good options. I'm just going to write a couple of these out. I can use greater than, right? I can use the equal sign, which is another math operator, just one that we're very used to. And of course, I can use greater than or equal to. And now if I go ahead and I run this, it looks like I actually have a typo. And this is just, again, a goof between the written curriculum and the database name. Services table is plural. This is a super common gotcha. I can promise that you'll all do this at one point, so it is good to see it. So this just needs to be services, right? So again, you know, I'd say stick with singular and try to be consistent with it, but just pick one and be consistent. And so this is really great, right? And this is like why SQL is great for reporting and business analytics and stuff, and why SQL and relational databases are sort of like the sharks of the programming world. You know, the shark evolved into its final form like a couple million years ago, and it's perfectly evolved for its niche and hasn't really needed to change all that much. And actually, relational databases have, but SQL and Postgres, they've been around a long time. There's alternatives, but they're not going anywhere. And this is why. Because if we work for JP Morgan and we need to start getting like some accounting information for all of our employees, this is a great way to do it. Um, there's also count. So let me just add some comments here. So these were our math operators. Now let's take a look at count. And this one's interesting. So let me run this and then we'll talk about it. Um, this is a little bit of a rhetorical question, but what did that query just do? What information did I just get?
Just how many records there are.
Yeah, how many rows there are in the car table, right? Um, I think it's a bit of a better habit instead of like count star to do count ID or something like that. Um, it's a bit it's a bit cleaner, right? You could do it with any column. Um, what we can also do is distinct. Let's see if I can get this right. This might not work. I might need to come back to this one. Yeah, I'll come back to that one later. We'll talk about how to get um like the unique list of colors because right now count doesn't really matter what column I give it. It's just counting all of the rows. Um, you can combine this with a where clause, right? So this is where it starts to get useful. Like how many cars are there that cost more than 40 grand? well if I had my clause right. And in fact, I think the issue here is with count ID. Mm, I think this may just be a naming issue. This is leading me wrong. Um, I don't think we have, this needs to be updated because this is actually not right. Let's see if we have price floating around anywhere. Otherwise, I'll just modify the query to do something else. Yeah. So what I do have, we don't have car prices, but we do have service prices. So let's take a look at that instead. So let's look at all of our services. So we've got three services here. One is 19.99, another is 29 bucks, another is 79 bucks. So let's look at all the services that cost more than $20. And the way to build this up, by the way, is start with a simple select statement and your where clause and get this working first. And now that I know that the query is working, now I can start to add on to it. And now let's add a count. And now I've got the number of services that cost more than 20 bucks. And I believe we should be able to run this. And this is actually a good moment to show the as clause, which lets us, just like if I'm writing some Python code, if I have x equals 5 and then I do y equals x, this is like almost an alias for x here. That's what the as clause is doing for us. And it's useful for stuff like this, especially if, say, we're building a report or we have a more complex query. You can make aliases for column names. So these two queries do the exact same thing. For this one, we just give this result column an alias that tells us what it is. We'll call it just services over 20. And I just want to check in to see if folks have any questions about count or building these queries with the where clause and as. Cool. How we doing? Awesome. So there's a number of other aggregate functions, and I'm going to kind of just move through them to give us a preview. And I'll give us a little more space here. I think I'll just leave the data model here off to the side for now. There's also sum, right? And this isn't that useful as itself because the service table tells us, just to remind us, if we go to services, how much each service costs. When we see the join query later, we'll see how to have this be a bit more useful to say get the total revenue. right now, what I can see is it's just adding up all of those prices of all of the services, right? So I can sum stuff up. So later on, we have this car service table. And later on with a join query, we'll see how to connect this to the services table. And then when we can use sum to get the total revenue of all the money that the shop has made from, selling its car repair services. But that's a little further down the road. Any questions about sum? Similarly, there's also average. So I can do select average price, and this will give us the mean. And let's just throw in an as clause here. And so this gives us the average price.
Could you find the average color?
Good question. From car. I don't think so. It looks like I'm pretty sure what this hint is telling me is that average doesn't like dealing with text because it's talking about typecasting. Yeah, but that's a great thought. To do what you're thinking, we would need to do something like um,
Couldn't you just do like a count and then like do each individual color and whichever has the most, which is like a bit more work, but
yeah, so this is getting a little bit ahead, but if we want to get, right, this isn't that useful. We're just getting all the colors. If I throw in the distinct keyword, all of the sudden, and as a reminder, let me grab all the colors and give us a little more room to look at this. So a bunch of different colors. Blue shows up twice, right? 10 rows in total. Select count just by its plain old self gives us all 10 rows. If I throw in this distinct keyword, we're telling SQL, I don't want duplicates, only give me rows that have distinct, i.e., unique values for color. And so then we get 8 rows, right? And let me copy and paste this into the SQL file so we don't lose it. And um, Jack, if we wanted to figure out all the colors, the query starts to get a little bit more complex. We might actually need to do multiple queries. And there's undoubtedly a way to have SQL also give us all the color names, and you can do subqueries and stuff. It gets more advanced. So it's a little out of scope of right now, but it is doable. But basically, what I really need, right, is I need the count for each color, and then we would want to maybe get the average of this. And that would tell us, you know, what's it's not the most common color, right? But it would give us a color count. So that's getting a little out of scope, but you can start to combine this stuff in that way. Yeah, great question. I love it. I'd love to dig into it. I just want to make sure I don't go too far down the rabbit hole here. But that's exactly what we can start doing is like combining this stuff more. And you can see how just even throwing distinct into the mix suddenly makes this super powerful, right? Maybe instead of, make instead of color, we want all the distinct makes of the car and we want to see them. Um, each car in there is different, so it's not that useful. Maybe we want to do where color equals blue. So we want to see all the number, the different makes of blue cars, right? Not really useful, but I think it illustrates how we can combine this stuff in a useful way, if that makes sense. Like, I don't need to know that, there's a blue Toyota and a blue Camry, but you can imagine other things like that would be very useful to find out that we can do when we start combining these things together. And we throw in as, and we call it, car makers with blue cars. And then all of a sudden, I've got a report from my boss, right? Because we need to know how many car companies make blue cars. Um, there's a bunch of other aggregate functions. Um, as with all things, the Postgres docs are exceptional, though a bit dense. There's aggregate functions for arrays for those of you who are messing around with like integer arrays to hold pizza toppings. You can use these in a number of ways. There's stuff for Booleans. You can see here there's count, um, every stuff for dealing with JSON, max and min. These are really good ones, right? In fact, we could do select max. Oh, excuse me. Let me just show max real quick and then we'll move on because that's actually a good one. And you can see how it's easier to type this out in pSQL. I want the record for our demos and notes repo, which is why I'm doing it this way. And that gives us the highest price service that we have. Right. So I would just take 5 minutes and just kind of skim through the aggregate function docs. When you're using them, this is also where I would go, right? Because now that we're getting more advanced, like to know exactly how something works, the docs are definitely the place to check out. Um, let's talk about, and actually, do folks have any questions around the aggregate functions before we dive more into where clauses? Cool. Let's talk about where clauses. And let me go ahead and just make a new file for this one. And we'll close that old one out. So I think I will leave this up here if this is useful for people to see, because this one should be more or less correct. So we've seen this basic example here already, right? This one is a bit more interesting. Like, lets us look for text within text. We're basically looking for a substring here. And if I run this, and the problem here is I forgot a second percent sign. Because what this percent sign says is I can have anything I want here and anything I want here, and somewhere in the middle is break. So if I did it this way, where I'm saying I'm looking for something that starts with break, that works just fine, right? And under the hood, this might be using some regex. I'm honestly not sure. And I can use this for you know, pretty much any sort of text finding. Like, if we just do this with the letter A and we run this again, uh, I feel like that should have worked.
It has to start with A, maybe if you do both of the percents.
Oh, I totally forgot. I did exactly what I was talking about. Thank you, Jack. There we go. Right. Not very useful with the letter A, but if we've got, a sentence we need to look through, um, maybe we want to find all the drivers with the same name. Do we have anyone with the same name in here? Uh, we don't, unfortunately. But if we did, we could do select
Jason.
star from, sorry?
Jason.
Oh,
Right.
Jason. Um, oh, I'm looking at the list of drivers
In
with
the chart.
SQL. Yeah, yeah.
Oh,
I
never
wish we had
mind.
us in the class.
Okay. I'm sorry. Yeah.
No, 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 you're good. You had exactly the right thought. We're named like, and we do have to put the percent sign in single quotes. Um, and let's put our closing percent sign. And it would help if I get the name right. And so there's only one Emily here, so this is not that exciting. But if we have like a couple Emilys, um, you know, or like this is more useful maybe for a last name, right? Everyone whose last name is Turner. So like is super powerful.
Is like
Uh,
doing more so like a comparison for what you're trying to find, or is it looking for something to include what you have with inside of your parentheses or your
it's
quotations?
looking the second one. It's looking to include what I have here inside the parentheses. So like this would find all services where the service name has the letter A somewhere in it. And under the hood, Postgres might be turning this into regex. I don't know. Um, so it's looking inside the string, if that makes sense. Does that help answer your question, Jack?
Yeah, I don't I was kind of just wondering if like I don't know if you like had the name of something but didn't know exactly how to spell it, if you could search it that way as well. But yeah, I guess I kind of answered it to no. You need to have what you need to have.
Yeah, exactly. Yeah, I think that you put it very well. You need to have what you need to have. You know, um, what you could do is you could try like a couple different spellings. Um, let me look this up to get this syntax right. Select where give me a second to make sure I get this right. Yeah. So this is getting a little more advanced. Um, let's forgive me. Let's bring back searching for the drivers whose last name starts with Turner. We haven't seen multiple where clauses, but we can start adding multiple where clauses. So I could do this, right? Maybe I don't know if it's Turner or Turners. Um, or I don't know, Tuner. And fingers crossed, this should run just fine for us. And we don't get anything exciting back because there's only one, thing that would match. But let's see, we got a Michael Johnson. So just for fun, let's change this to Johnson. Um, oh, and I'm running the wrong thing. And then we get back our two results. Um, we can also add an and conditional logic. So while initially this query gives us two people, now that their age also has to be greater than 33, uh, I would have thought that I must be misinterpreting how the ors and ands are interacting here. I might need to add a parentheses. Let's see if this does it. If not, I'll move on because I don't want to get too lost in the sauce here. There we go. So I think what was happening was with the Boolean logic, like because these ors were returning true. I'm not sure the and clause was getting triggered, but when I bundled this up so that all of this becomes one, true or false, and then we have an and, then SQL gets and it's like, okay, I need all this to be true, and I need this to be true. A simpler example would be select star from driver, where name like Johnson and age greater than 33. So far, so good, right? If I increase the age, we don't get anyone at all because we've got an and clause here, and both parts of that are not evaluating to true. So the where clause is really powerful because we can start combining stuff. And I just want to see if folks have questions around this, because I know I kind of threw this one into the mix, but it also hopefully kinds of builds on everything we've been seeing. Cool. And the last thing I want to show everyone, and this is kind of circling back to the like clause, is I like. I like is not case sensitive, which is frankly a good thing. Because that would not work with like. All right, let's go ahead and run both of these. We can see with this first one, the like totally fails because of case sensitivity, because I've got a lowercase j in there. When in the database, it's an uppercase j, but I like is not case sensitive, right? So I would kind of stick with I like because it makes life easier. It's very rare you need to care about case sensitivity. So that I like is a good one. Let's take a look at the in clause. And actually, let me see if folks have questions or if there's anything that folks are curious about before we take a look at in. Okay, awesome. We're going to look at in and as. We've kind of covered like. I realize we're almost on the hour. Actually, why don't should we take a short break? You all want to take 10 and then we can pick this back up? Okay, let's do it. Let's take 10. What we'll do, let me pause the recording and then I'll share the plan. All right. So we've got a couple other sort of aggregate type query clauses that we can add. Some of them we've seen, some of them are new. In is a good one, right? If I want to look at all the cars from that are in a group of IDs, I can go ahead and run that. Um, and I could do the same thing, right, with services or drivers. It doesn't have to be an ID, but I think for in to work, it does have to be a numeric value. Though this actually might work. Let's see if this works. Yeah, so this works just fine, actually. As long as it's exact string matching, this is good. Um, if we try to throw an I like in here, though, that that won't work. Postgres should have a function to lowercase stuff, and it would make sense for it to be called lower. Um, so I think this will do what we want. Yeah. So this is another way to construct this query. And this shows the power of Postgres functions, where I'm telling Postgres lowercase the color column. So I don't have to think about case sensitivity when I'm putting my exact matching here. There's other ways to construct this query with I like, but this is a nice way to do it. Um, we've talked a bit about as and alias in columns. I can add as many aliases as I want. I did get a little lazy here in uppercasing, which again is not necessary, but is there just for convention. Um, again, where it really becomes useful is with the aggregate functions like count and sum. Like if we want to see the average price of a service, well, I can run this. And in fact, we might want to do a little work to get this average rounded just to two decimal places, but it might also be nice to do something like this so that our result column is a bit more meaningful, right? Um, if I want to, when I'm using these aliases, I can also use the alias in a where clause. And maybe I cannot use it in the where clause. Yep, I apologize. Let's see if that works. Yeah, I apologize. This will come up later. I got a little confused. We in fact cannot use the aliases in the where clause. That's gonna give us an error. Later on, we will see like we can use aliases. I think it's in the aggregate functions and other things, but I think the where clause needs to be referring directly to the table. We've already talked about like a good amount. So I think we've kind of covered everything here. Limit becomes super useful, where we can limit the number of results. It becomes super useful when we combine it with descending and ascending. So let's say I want to find the 3 oldest cars. Well, I could do select star from car order by year. I think ascending would give us the oldest, right? Oldest to youngest. And so indeed, I see the oldest years, right? We're going in ascending order, but I want to see the 3 oldest cars on the lot. And now I've got the 3 oldest cars, right? So ascending, descending, and limit become very useful, right? If I want the oldest car, I could just do limit 1. So if you combine ordering with limiting, it sort of functions as its own filtering, if that makes sense. And I just want to check in to see if folks have any questions around order by and limit.
I mean, I get that we could just switch the order from ascending to descending to get what I'm about to ask.
Mhm.
But is there a way to grab like I guess the last indexes when you're doing this as well?
What do you mean by the last index?
So like how we have the car and we wanted to limit it to the 3 if we want to get like the last 3 from that ascending list instead of the first 3.
Oh, no, because limit is going to start. What this query does, it kind of under the hood creates its own table, which in fact is sort of called a view. And so the same like what happens here is as soon as we do this order by, all the rows in our table are ordered in that way, and limit will just start at the beginning and grab the first 3. There might be some tool to start from the end of the table, but honestly, you're probably best off just messing with order by. Yeah, good question. All right, let's take a look at group by because this is a good one, and I think this is where it starts to get a little more interesting. And this actually goes back to someone's question from before. Let me go ahead and comment this stuff out. And let's give us a little room to work with. So let's say I want to see how many makes, like how many Toyotas, how many Hondas, how many different makes of cars I have. Group by will let me do that. So group by sort of bundles up results. Now, it's not very interesting here because there's only one model for each car, right? If we look at all our cars. But if we do this, say, for color, and this goes back, I think you were asking this question earlier, Jack. Um, this is actually the way to do it. We'll call it car color, or we can just actually call it car count. Oh, I'm running the wrong query. Forgive me. My brain has totally. So this is what we want to look at here. In fact, let me just clear it and run it again. That's what I was looking for. So I think this gives us a really good example of what group by does, right? The select query is still doing its thing, but if you look at this count, this wouldn't make any sense without the group by. In fact, it wouldn't work, right? Because what am I counting in each row? But with group by, we're telling SQL, all right, look at all the different values and group up all those columns. And then for each group, right, give me this column and use this aggregate function, right? And we're aggregating the value for all of the columns in each group. And I think we could even do, maybe we only care about the primary colors. And let's see what this didn't like. I might need the where clause to be there. Let's see if that does it. Yeah. So normally the where clause is at the end, right? But with group by, we need to put group by last. So here, this is cool because I can get a count for the colors that I care about. So group by, without the where clause for all of the colors, and group by with the where clause. And this is a good one. We'll throw a couple other examples in here. So I do want to check in and see what questions folks have. How are we feeling about group by?
Well, so I imagine like order by, might be another one that maybe is better off, last, in the query, listed last in the query.
Yeah, I think order by probably needs to be last. And in fact, we can probably do order
And
by.
and limit maybe also. I'm not sure.
Yep. Yeah, I think you're right. Limit and those would have to be last. What I always get confused is, you know, I always want to think we group and then we do the filtering with the where, but that's not how it needs to be written. Um,
Actually, limit's probably like last even after like group by or order by.
yeah, limit's definitely going to have to be last. Um, in fact, let's combine them all together and see how many typos I have here and run this code. And we're error free. And so this is really cool, right? Because now we have the most common colors ordered descending. And if we only care about the top three, we can do that here. And here you can see what I was trying to do earlier. I can't use my alias in the where clause, but I can in the order by, right? And you can see that here where I'm using card count, where I've got this alias here. So you can use the aliases in order by. You can't do it in group by, I'm pretty sure, and a couple other places. Let me show you all one more thing with group by that's a bit fancier. And before I dive in, I just want to see if folks have any questions on this one. Cool. These are really good examples. Group by gets a little tricky in practice, but it's very powerful and you'll definitely need it. So I would definitely make sure to refer back to these. Let's look at some more advanced group bys and you can kind of see it here. And I'm going to type it out and then we'll talk about it. So SQL, as you all can see, really is a programming language. It has all this stuff. We're only scratching the surface. You can make variables, you can do subqueries, you can create your own functions, but like really like the fundamental like 30 to 40% we're looking at now is where you get like 80 to 90% of the value. So like any programming language, we can even do a little bit of conditional logic and variable creating. So when we're doing group by, we can create some different values, basically. And that's what we're doing with this case setting. And we're saying, and we're going to, by the way, be working with the services table. And we are going to want to group it by price range. And actually, the best way to build this up, and let's grab the services table here so we can see how to construct this. So I just want to get a little bit of something going here. Let's do, and in fact, let's insert into services, name of service, price, values, higher rotation, 29.99. Let's see here. Interesting. So we'll have to do it this way. I'm just going to manually pass in the ID because we're running into the same issue that we had the other day, and I don't want to deal with it at the moment where we have to like update the sequence. There we go. And now I've got two services with the same price, which will make our querying a little bit more interesting as we do this. So let's select ID, count, price from services, group by price. Let's see here. Must be, yep. So this is a good gotcha, actually. Once you use group by, because it's grouping up these values, what this error is saying is, hey, I don't know how to combine IDs. Like, I need some sort of aggregate value. So, in fact, we really don't want this. We want this. And there we go. We want this, right? Where the only column we're selecting is one of the aggregate columns. So this is a good starting point. And this is how you design and construct more complex queries. Start simple and build it up. And what we're going to do now is use this case when behavior of the SQL language. And we are going to create essentially some variables and some if-then statements, really some switch case statements to stick prices into certain ranges. And we're going to use that for our grouping. And give me one moment here as I have to send a quick message. All right. So let's go ahead and build this out. So if price is less than 30, we're going to call it low. If price is less than 50, we'll call it medium. Otherwise, we'll call the price high. And what I have to do is I need an end statement. I need an end, and that's just sort of the syntax for this case when logic. And I need an alias because we need a name for this. Oh, I'm so sorry. I'm getting confused. I do need an alias, and I need an alias here. And we're going to call this the price range. So we're basically creating values and we're doing some switch case if else conditional logic. So SQL will know what prices go in what groups. And now let's do our count. And now we can keep from services and group by price. And if I was constructing this for real, I would definitely have the Postgres docs up or a tutorial as I'm building this. let's see here. I have a syntax error hiding somewhere in here. It is probably, I'm missing a comma.
Is it like the arguments? Because it's gonna say anything above 50 is just medium and high.
Um, let's see if price is less than 30. No, we'll see if we run into that. My guess is it puts everything, it goes through this condition first, then whatever's left, it deals with this condition, then this one, that it's doing it in order. But that is definitely a good thing to think about because other programming languages or sort of features could behave differently in that way. You're right that ideally we should be a bit more specific. Let's see if this works. Yeah, the issue here really was like all this stuff here is basically one column, like sort of that I'm constructing, right, in a super fancy way. I didn't have this comma at the end. The same way if I was doing like ID name, I need a comma between columns. I think that was my syntax there. Let's run this again and see if that resolves the issue. Yeah, there we go. So good question, Jack. I don't think that's happening. We can do select star from services. From So we've got 4 services in total. And if I go back up here, I've only got 4 in the count. So I'm reasonably confident it's not duping and duplicating stuff. So this is a bit fancier, right? And I know I've kind of thrown this into the mix, but I think this is good to see. Again, the Postgres stocks are good on this. You probably won't have to do this on the assessment, but it's really good to see that you can do this, that we can sort of create these categories, that we can use our aliases, and then we can combine it all with group by to do some really powerful reporting, right? Um, any questions on this before we break for a little bit of independent work time? Okay, cool. Let me stop the recording. All right. So we are going to talk about SQL joins, and this is really the big boy for today. This is when stuff gets exciting. We've done all these great queries, but they've all been about getting data from one table. Joins are about getting data from multiple tables, right? If I hop back to my data model, it sure would be nice to say, be able to see all the people who drive a Toyota, right? And get their names. And we've been setting up these relationships with primary keys and foreign keys, but how do we use them? And that's the problem that the join clause in SQL does. Without getting too deep into the weeds here, there is like a solid math foundation to the structured query language, SQL, and relational databases. And it's the math of what's called a set. And sets are just groups of things, right? And in fact, let me pull up, we'll use one of these existing diagrams. Um, you guys have all probably seen like a Venn diagram like this before, where, to go back to SQL, maybe this is like, people who like cats and people who like ice cream. And then in here, where these 2 circles in our Venn diagram overlap, is the people who like cats and ice cream, right? And over here are the people who like cats but don't like ice cream, and the people who like ice cream but don't like cats. And that's sort of the nutshell version of like, what is a set? It's a collection and they can overlap. And our sets are our tables. And a join is about combining these in different ways. And we'll see the different ways to do that. And this is where the foreign keys come into play, because we do need to tell SQL how to connect these two tables, right? If I've got all of my cars, and let's see how clever, lovely. So close enough, right? We've got the cars in here. And the drivers. Well, if my SQL statement is going to be select, let's just say star from car, join driver on car dot ID equals driver dot ID. And in fact, let me go ahead and write it in here. And let's go ahead and run this.
You did the backward slash.
Oh, no, that should be right. I think. I see. I created the joins file in the wrong spot. Let's open it up again. Let's try it one more time. There we go. So this is a lot of stuff. I'm getting all my car information over here. Oh, forgive me. There we go. All my car information over here, right? Every single column from car. And then all of my driver information over here. And we can see the matching is in fact on car ID and driver ID. Let's see if make sure I have this right. Actually, I think I have a bit of this wrong here. Yeah, forgive me. I got a little confused because our naming convention is a little different. We really should rename this driver column to be driver ID. That's what we're looking for. There we go. So from the car column, this driver ID is our foreign key, right? If I'm hopping over here to draw SQL, I've got car, the primary key over here, and this foreign key ID, that's the driver ID that connects here. And the join query uses these to connect the rows in the way that it should. So here I see all of this information, right? And maybe instead of everything, what I want to see is, oh, driver dot name and car dot make and car dot model. And now I can see the names of people and the cars that they own. And this is the essence of a join query. right? And to kind of use the spreadsheet as the metaphor, like we're literally finding from here. I'm saying, all right, this driver has an ID of 1. Well, let's find the car with a driver ID of 1. And it looks like there might be 2 of them, in fact. Or I might be misreading it. But here we've got Michael Johnson owning a Toyota Camry. So that's one result row in our join table, and so on and so forth, right? Here's David Miller, and David Miller owns a silver Chevy. And let's join those 2 rows from these different tables together to make this new result row. So I just want to check in and see if folks have questions around the basic operation of a join and what it's doing. And how are we feeling about this step? Because we're definitely going to be building on this. Cool. I see a couple thumbs up. Sounds good. We can do all the things that we've been doing that we like. We could filter, right? Maybe I want to find all the people. Sorry, let me get the Zoom annotator out of the way. Note that over here, I can't just say column names anymore because 2 tables could have a column with the same name. I need to do table.column name. So once you do a join, you'll want to do that as a habit. I can add aliases, if I want here. And that can be useful as we're doing this. Oh, and I need to get rid of the where clause that I haven't built yet. And we can do the same filtering that we've been doing, right? Where driver.name, and let's say we want everyone whose names start, man, the names don't even start with the same letter. Let's just say everyone whose names have the letter D in them somewhere. And that's everyone whose name has the letter D in it. So we can do all these things that we're used to doing, right? I can do group bys, I can do counts, I can do all of our aggregate functions. It's super useful. So that's kind of where this like Venn diagram comes in, right? The join initially, really, we're getting everyone. But it could be, and actually, let's add someone who doesn't have a car. Because if I look right now, there's 10 cars and 10 drivers. Let's insert into the driver table. Actually, let me do this in the SQL because this will be good to save. Let's see where we have someone missing from the Venn diagram. ID is going to be 11. Name is going to be Bob. Phone is going to be 1, 2, 3, 4, 5, 6, 7. Email is going to be bob@gmail.com. And age is going to be 33. And let's insert Bob first. Let's do a join afterwards. Let's not worry about the where clause. And let's see what happens. So there's no Bob, right? All of a sudden, we really do have a Venn diagram because join gives us all the drivers that have cars or all the cars that have drivers, right? And Bob is over here, but Bob doesn't have a car. So this is part of the power of joins, right? Because a lot of the time, we're going to have drivers without cars. We're going to have students who haven't enrolled in a class. We're going to have employees with no paycheck stub from last year because they just started working at the company. So this is a really powerful part of joins is that a lot of the time we don't always, have matching values for everything. And join gives us where they intersect. And I just want to check in to see if folks have kind of questions around there or things that people are curious about.
Um, so if you're like trying to check on drivers who don't have a car, how would you do that?
Yeah, totally. Great question. So I don't want the intersection. I want this part over here. I want the drivers who don't have a car. And I may need to modify my syntax, but I believe that is a left join. And let's run this and see if this does it. I might have to tweak it a bit. Duplicate key. Oh yeah, we don't need to keep inserting Bob in my SQL. So I think I need to get the right term. Yeah, I think what we need is left outer join because this overlap here is what we call an inner join. And there's a great image that I'll share with you all here later and a great article. And you can actually see it really clearly here. And let's just kind of walk through this real quick because I think they do a great job of this. So the default join, if we just say join, it does what's called an inner join. And it gives us this intersection, right, of drivers who have cars, right? We've got drivers, we've got cars, drivers who have cars. A left join should give us drivers without cars and with cars. To get what you want, it's called a left outer join, I think. There's a couple ways to do it. We might need to add a where clause where we want null for Bob. I think we can also add outer in Postgres. Let me kind of construct this and see how we do. So let's start out with left outer join and let's see if that does it. And if not, I'll probably have to add the where clause. Yeah, so this is everyone right now. Let me make sure Bob is in there. So Bob is there. And it looks like Bob isn't even showing up because he's being excluded from our left join. Let me make sure I'm getting my Postgres syntax for this right. Yeah, I think it should be. Let's see. Yep, my apologies. Let me just tweak this because there's something simple that I'm missing here. But then we can show this, and this is good to see it. No, I feel like we should have this. Oh, yeah, I think I know what I'm doing wrong. Let me leave that there as an example. Let me construct this again, and we can talk about the difference and see if this takes care of it. The select part will be the same. Instead of from car, let's try from driver. Let's see if this resolves it. Yeah. Okay. So this is a little subtle, right? Because I was not seeing this. Um, Now that we're talking left versus right joins, all of a sudden it starts to matter which table I say in the from statement. This first one with car, when car was on the left and we're doing our left join, we're never going to get Bob in there no matter what, right?
Is that because
With,
Bob's not in the car table?
yeah, because exactly. Because with from car, the way to think about it is car is the first one. And so car is going to be on the left. And then the next join is to the right. And if we did more joins, I think we'd just keep adding to the right. And exactly like you're saying, like, because Bob over here, and let's throw in like Alice and Michael, just so we have some other examples. And we'll throw in here you know, Alice's Toyota, just so we can see some stuff. Right. If the cars table's on the left, it doesn't matter if our join is left including the intersection or left outer excluding the intersection. Bob isn't in it no matter what. You see what I mean? But if we put drivers on the left, which I do here because I say from driver, right, instead of from car, and you can do right joins too, but it's a better convention to kind of use the left as your starting point for this kind of stuff. Now, a left outer join includes everyone. Um, I think a left join will do the same thing. Yeah. And now if we do where make equals null, this was the other, uh, I'm not sure driver ID null was the right thing there. We can test that in a sec. Um, I think actually I may just be getting confused that I need is null. There we go. That's what I was looking for. So our left outer join will get us all the stuff on the left, but we kind of still need this where clause to filter because the left join to get like an exclusive outer join, we need the where clause filtering basically. I don't think a left outer join on its own does it, which I find a little confusing. There might be a better way to do it, but this is a pretty standard way to do this, right? Where you have a left join and then we filter on null to get so we get the things over here, right? Because for everyone who has a car, car.make is a valid value. So we should also be able to do here, like where driver ID is null. I think that should work. No, it doesn't like that. It has to be one of these columns in the select statement because that's what the where filtering is happening on. So the where clause really has to be addressing one of these columns. So this is an exclusive left outer join, right? Drivers without cars. And I just want to check in and see what questions folks have on this because I know I had to do a little bit of debugging along the way there.
Yeah, I do have a question. Car.driver. I mean, a driver isn't an ID, right?
In this case, it actually is. We really should
Okay.
name it something different. Um, that I think that is a bit confusing, but yeah, driver is a foreign key on the car table.
Oh, okay. Thanks.
Yeah, for sure. That's our bad with the off naming convention there. Yeah, what other questions do folks have? What else is on people's minds? How are we feeling about this join statement and what it's doing, getting us Bob and cars without drivers?
I think it makes sense, but actually putting it in practice in our own tables, for me, it will be a bit struggling through it probably.
Yeah. Well, let's build a couple more joins. Let's build a join. Um, let's see maybe like all the cars that have been serviced and all the services that have been done to a car. So if I want to see, and let me scroll up a bit here so we can kind of have the data model here as a reference. Um, let's just start with service and car service. Let's say I want select services dot name of service services dot price. And I think what I'll do is I'll kind of put here just on another, or I'll just leave it here. And then let's say car service dot car ID from, and can someone help me build a join here? Right. I want to I want to see the service, the price, and the car ID.
From service,
Yep.
inner join. Oh, wait, is it maybe left join or?
Yeah. We can just say join. It is a little confusing. Join by default is an inner join, like we see over here. Um, it, it might be a left join by default. Postgres default join. Okay, the default join is the inner join. Yeah. So
Inner join.
default
Okay.
join is inner join. Yeah. Awesome. Morty, you're on a roll.
So join. Sorry. Well, inner join. Join car service
Yep.
on service.id and car service.id. Or wait, dot car ID, I believe. No, wait.
Yeah.
Uh,
Well, take a look at which ID is the foreign key connecting service to car service.
oh, it's service ID, right?
Yeah, exactly.
Service ID. Okay, perfect.
Exactly. We're gonna get there. We're gonna connect, we're gonna join up three tables in just a minute. Um, I think this looks good. Let's um give this a run. I'll just throw in well, we can throw in an order by once we get it working. And we're cooking. I think I'll throw in an order by price descending. Because that I think will be nice to see just to help us kind of see it more clearly. And now we've got all of our services and all of our cars. And I think every single car here has been serviced, right? To go back to our diagram for a sec, we now have service over here and cars. We don't have some car never serviced, right? And then over here is all cars, serviced, all services used. And over here would be some service never used. Right? We don't have any unused services, so this is empty. But if we were doing a left outer join, we could find that. And here we could find that. And let me actually throw in a couple things into the mix here. Um, let's see, what do I need to add a new service? Oh, just a name and a price. Perfect. Insert into services, ID, name of service, price, values. I'm just going to come up with a ridiculously high primary key. 20, never used, 500 bucks. Right? And that's why the service is never used. And so now we have a very expensive service no one has ever used. Can someone help me modify Morty's join query so that we see all the services that have never been used? All right, so I want this over here. So how do I need to change this join query so it's not an inner join, but it's a left join, and we're only getting the things that don't exist in the intersection? So there's two steps, right? First of all, what do I need to change on line 35?
Left join.
Yeah, exactly. We need to specify, hey, this is going to be a left join. And if I run this, and let me go ahead and just comment this out. I see my never used service, and it turns out tire rotation is never used either, right? But I need to filter these results so I only see the services that were never used. Right now, I'm getting everything, right? But I only want this. So how can I then filter in this query to only get the unused services over here?
Where car ID is null.
Yeah, exactly. Awesome. And thank you very much, Morty. I appreciate it. Where are we kind of, let's see, we'll do car service,
Car service.
car ID. Yeah. Is null. And fingers crossed my syntax is correct here. Awesome. Thank you very much, man. Great job. And so now we've got another left exclusive join, right? And the two things we have to change, we have to tell SQL, hey, this is going to be a left join, but that's going to get everything. So we do have to then use the where clause to do the filtering. Do folks have questions? Is there another example folks might like to see before we dig in a bit more and look at some other joins? Okay, cool. Let's start combining joins, right? Because it'd be really nice to maybe see some information about the car as well. So let's build another query. And if I hop back to my data model, really, I think what I want to see is I want to see a driver, I want to see their cars, and I want to see service information. I want driver, car, service. So we're going to do a whole bunch of joins. We're going to be looking for drivers who have cars, cars that have been serviced, and then obviously every service is going to have information about it in this table here. So I'm going to build this out just with star to start with to make my life easy and to avoid typos and mistakes. Select star from driver, join car on driver.id equals car.driver. Join car service on car. Now I have to get this right. And this is where I always have to kind of like pause my brain a bit to make sure I'm thinking through IDs and primary and foreign keys. Car.id equals car service dot car ID. And let's actually just run this and make sure this works before we start adding more stuff and making it fancier. It runs. Great. It's more information than I need. Now let's start getting a little more specific. Let's do driver.name as driver name. Let's get, I think I want car.make as car make, car.model as car model. I think I also want, well, we haven't gotten to services yet, but let's do car service ID as car service ID just so I can see it. From driver, join car. So hopefully I haven't done anything silly here. I haven't really modified the core query logic. I've just tightened up my select so it's more readable. Can I get a volunteer to take us home? And now that we've connected car to car service, how can I modify this query so that it also shows me the name of the service and the price for each service? How about Jack? And you can phone a friend if you're not sure. Uh-oh, did we lose Jack?
I think he's gone. I'll just go. You can do join services.
Yeah, thank you. Are a bunch of folks not here at the moment, or what happened?
Did
I,
launch?
I think this is just complicated. That's all.
Oh, okay. I
Okay,
think
all right.
launch something.
Yeah, it's
Yeah,
a bit complicated, and I'm also fighting Zoom. It keeps turning my camera off by itself.
okay, that's good to know. Noah, why don't you take us through this and then we can untangle the complication.
Okay, so it'll be join services.
Okay,
and it'll be on car underscore service um, dot car underscore service underscore ID.
Oh yeah, thank you. Service underscore ID. Yep.
Okay, and it'll equal the services dot ID, I believe.
Yep. Exactly. And I'll throw in here services, name of service, and services dot price. Awesome. Thank you, Noah. Let's give this a shot. And then what we'll do is we'll do a couple simpler joins with some more volunteers. So this is looking pretty good, right? I've got each driver, I've got the car, make and model, I've got the service ID, I've got the name of the service, I've got the price. That was awesome, Noah. Thank you. Let me do another volunteer. And Jason Anderson, I'm totally picking you here. Semi at random. I want to get query to get car make, model, and license plate number. So I'll build out the beginning of it. Select car.make, car.model, plate.plate number from, and Jason Anderson, can you help me build this and maybe what the next step might be? Or if you're not sure, you can phone a friend.
It'd be from car,
Yep.
and then join car dot make or from car, join car.
Well, the join, you're on the right path. This is, and in fact, I think a good way to do this is actually with SQL. What does a car have? It's got an ID, it's got a make, it's got a model. That's really all we care about, right? What does a plate have? A plate has an ID, a plate number, a car ID. And we'll say the plate is purple, the car is green. Let's just throw a couple in here.
Okay, so you join plate on car dot ID
Yep, exactly.
and plate dot car ID equals plate dot car ID, right?
Yeah, yeah, I think you're on the right path. You were saying join plate on car.id equals plate.car underscore ID.
Mm-hmm.
Yeah, exactly. Right. Because this is our primary keys here for car. And over here, this is the foreign key that does the connecting. Yeah, exactly. And so we can do, and I think kind of drawing it out this way can be useful. Like we can even like, let's put these over here. And in fact, if I'm going to kind of play around with this, we can put these over here and let's put the car ID here. And we can really see how they match up, right? And this part is our join. And this is exactly what you did with the join statement. And that's what we're constructing right here. Does that visualization help
Oh,
a bit?
yeah, now I see. Now, so this is, I think now I get it. It's just making an impromptu join table, kind of.
It's exactly what it's doing. And
Okay,
it's in
okay.
fact where the term join table comes from.
Okay, okay.
Yeah. Is this visualization useful for folks as well? to kind of see what's going on here? Yeah, awesome. And again, for all the cool stuff we can do with SQL and for all the set diagrams and the nice diagrams here, really the concepts are just table rows and columns. And 99% of what we could do here with, pieces of paper. If this was 1940 and I had a ledger of cars and a ledger of services and I had to look stuff up by hand. And so I think as you're doing this, that's honestly the way to go. I would bust out a spreadsheet or even a piece of paper. And if you just think through, like, man, if I had to do this by hand, how would I do it? That'll help a lot because that really is the fundamental concept here. I think we're looking good with this query. And Jason, great job, man. Let me go ahead and run this sucker and let's see how we are doing. So I just have a syntax error that I need to fix, and it's because I don't have a closing parentheses on this old query, which is going to be not what we want anyway. So let's give this another shot. And there we go. We got the make, we got the model, we got the plate number. Nice. Awesome job, Jason. Thank you. Do you want to pick our next volunteer or voluntel?
Oh, geez. Eeny, meeny, miny, mo, Chase.
Okay, cool. Chase. Anyone I can definitely, I have a couple more things in the mix that I can throw in here, but does anyone have like a request for maybe a join query for Chase to construct or something to add on to this query? Anyone curious to try something out?
I put it in the chat um to modify the query from 40 to 46, if you can do that one.
Oh, from this one? Yeah, let's
Yes.
give it a shot. Okay, let me comment this one out. Let me bring this one back in. All right, this will be good. It's Rachel and Chase. This is a big one. Um, and I think real quick before we dive into modifying it, let me just build out what we're seeing here with this query, with the spreadsheet visualization, because I think that will help a lot for folks. So we have a driver, right? And we have a name. Um, we have an ID. We then go to car, and car has the driver ID, and it has a make, and it has a model, and car has an ID. And let's go ahead and let's like use a little visualization here so we can see this nicely. Let's give this a big border, and we'll kind of make this one red, and we'll make this stuff red, and we'll make this stuff blue. And Rachel, we'll definitely get there. I think we're good on time, so we'll be able to hit what you're interested in. Because we have a driver, we have a car, and then we have car service, right? And that has car ID, and it has ID, and it has service ID, right? Because this is a big join, because this is, I think, 4 tables. And this one will be, how about yellow? And then we've got join services on car service. And we finally have to throw in services, which has an ID. It has, what is it? A service, a name of service, and a price. And we'll make these, green. And I'm only going to add one here in the interest of time. And then we can see here, like right here, we have a join, right? Right here, we have a join. And then right here, we have a join. And Rachel, thank you for being patient with me throwing that in there. What was the modification that you wanted to see to this query?
I put it in the Zoom chat, just grouping by person to try to see the total number of services per person. Because if you go to the table, you have like the driver's name repeating.
Mm-hmm. Because a couple people got the same service. Yeah, I agree. That sounds like a good one. I think we can just do driver name. And let's see if that does it for us. So this is where it gets tricky, actually. Right? Now that we're doing group by, all of a sudden, all of these columns that Postgres doesn't know how to aggregate throw errors. So we're going to have to do a couple modifications. This is a great one, Rachel. Thank you for suggesting this. Let's do this. And then, Chase, I will throw one more join your way for us to build. And is this visualization helpful for folks, by the way, in seeing what's happening with our monster four table join? Awesome. Yeah. And again, I really think just like using SQL and thinking about like if I had a pencil and paper, how would I do this will help you kind of understand what Postgres is doing. So the issue we ran into here, this error column car make must appear in the group by clause or be used in an aggregate function, right? And this is the tricky thing with group by. Once we use group by, every single one of these columns has to be either what we're grouping by or we have to be able to aggregate it somehow. So car make, probably out, right? Car model, probably out. The simplest way to do this is sum services price as like total service cost. I think that will do it for us. Let's give this a shot. Yeah. And so now we can see the total services cost. Now we can do interesting things. We could do a count. Distinct services. What is it? Service name of service. As And in fact, it's time to start, I think, putting these on separate lines. Let's see if I got that one right.
You have a typo in line 56.
Oh, thank you. I see it. There we go. Thank you so much, Chase. Yeah, that's the tricky part. The SQL messages, actually, that one's pretty good. So that works, right? So Rachel, that's a really good one to see because we can totally do a group by, but we do have to change what we query for so that Postgres knows how to aggregate it, right? There are ways, like if I wanted a list, I could construct a list of all the service names. It just gets a little more complicated, so I don't want to open that door right now. But this is probably useful to see how, in this case, this part was really easy, but then we just have to kind of rethink what it is we're getting so that Postgres can aggregate it. Rachel, does that kind of help illustrate what you were interested in?
Yes, I think like it's also helpful to see because even if you just want to get a couple things, you still need to do a bunch of joins.
Correct. Though, truth be told, um, yeah, I think you're right for this one because we kind of need the car because car connects to service. car service, which connects to services. And if we want the driver name, we need that. And that is, you're absolutely correct. And that's very common with a data model. And it's not necessarily bad because once you get used to joins, you guys can see here for your sort of standard inner join, this is a pretty repeatable pattern, right? I think once you get kind of the right mental model and the visualization, then it starts to click. If we wanted to, we could have connected car service to the driver, right? But then we would probably still need the car ID because what if someone owns two cars? So that would have let us go from driver to car service to services in 3 steps. But that's a different data model, right? So you're right that it opens the door too to thinking about like trade-offs in our design. And in general, the simpler is better approach is always a good starting point. Yeah, that was a great one, Rachel. Is there any more that you want to kind of dig into or that folks are curious to add on to this one? And Morty, I see your question about total. I would have to look that up. If you mean sum, we can use sum like the total count. We would use it
You
here in the
already
select part.
you already answered it with
Oh,
count. So
got it.
it's sometimes it's confusing to figure
Yeah,
out what's applied in the where clause. And
yeah, totally. All right. Um, let's do one more of these. Let's do one more join. Let's let's do a join. Let me show you all a right join just so we can see it. So what we're going to do for our right join is we're going to go with services and cars. Um, we'll put cars on the left and services on the right because not sure if we have any unserviced cars in there. And what I want to get is the unused services, which we did before, but we're going to do it with a right join. And since we haven't seen a right join yet, I'll just build this one out. So we're going to do select service dot name of service. And that's really all I'm going to do from services. I think that's services table. Oh, oh, I'm so sorry. From car. This is a little backwards. Um, if I'm being honest. But that is okay. I'll build this out and then we'll throw in a little bit more to make it a little more interesting. We'll right join on car dot ID equals services dot car ID. And let me run this real quick to make sure that this basic query is correct and doesn't have any typos. Let's see. Right join on. That's how we know it's lunchtime when the errors start to increase. Um,
Were you just trying to get the services that were not used at all?
yeah, but I wanted to do it with a right join.
It does say you have to do right join excluding inner join.
Oh, interesting. Okay, let's see if I can get. Yeah, I think
we have to right join something, right? Right join what's on car ID. Is it right join service
Yeah,
on
I'm
car ID?
actually help me fix this Postgres SQL query because I can tell my brain is starting to fade a bit.
Oh, service. There you go. Service.
Is that really the only issue that
Yes, you're missing service. Service on. Right join service on.
oh my God.
There you
Thank you so much. My eyes just did not want to see that.
go. Okay.
Yeah. And let me make sure that, yeah. And this is like, you don't have to write your queries exactly in this style, but however you do it consistently to help see this stuff. Like, because I think if I had put the on a separate line instead of having it like this, I would have seen that a lot quicker, right? Because if you're looking at this, then Morty, what you were seeing jumps out a bit more. Let's give this a shot. And Chase, we still may need to do a bit of what you were saying to get the exclusive right join, but let's just get um, column services and we have service ID. Um, oh, I'm forgetting the extra join that we need here because it's car service. We're going to simplify this a bit. I apologize. I don't want to show. Yeah, my apologies, folks. It's definitely lunchtime. Right join car service car ID equals car service dot car ID, and that should do it. I was totally blanking here. We're connecting car to car service. I was trying to jump straight from cars to services, and that was part of the problem there. So let's see if we can get this cooking now. Um, and indeed, car.make, it's not car.name. And this needs to be changed as well to car service. We'll just call this. There we go. Thank you for your patience. Definitely lunchtime. So just to recap, I was trying to go straight from car to services. That is not going to work. We need to connect car to car service. And so I'm grabbing the car make, the car service ID. Car is on our left here. And car service is on the right. And with the right join, I think we're still seeing, I don't think we're quite seeing all this unused services yet. I think there should be a service for. Um, we might have to go back to what you were saying, Chase. If we look at all the services, um, I should be seeing the service. Oh, yeah. I apologize, folks. It's definitely noon. I'm kind of constructing this the wrong way. My brain's definitely a bit tired. Um, I'm running into trouble again because I want to get a service ID of the services that aren't used, but that's not gonna exist in this car service table. So we need to back up one more step again. And now we should have this, and then we can take it home and wrap up. And the good news here is you don't need to use right joins a lot. And as you can see right now, really the issue is just, it's time to take a break. What we're going to be doing here is connecting car services and service. Let's see if this does it. There we go. So I do apologize about that. What we now have here is, and it looks like someone did use this never used service.
Well, on that, were you trying you just pulled up all the services and not the unused ones?
Yeah, we have one more step here.
Okay.
And to help me avoid losing my mind, I'm adding some, let's see, car service ID as I'm adding some as clauses just to help me keep track of what's representing what here. There we go. Yeah, thank you, Chase. I was also just running the wrong query there. I was running a select. So we've got our car service ID, and this is like a record of service. This is the ID for the service of itself, like an oil change or whatever, and then here's the name. And we can see all the things. And finally, down here, we have the two things we want. So stepping back, as you can see, the join here is not that hard. The hard part was it's easier to think left to right than right to left. And most of the time, we don't need to do a right join, to be totally honest. And here we can again just do where car service.id is null to filter stuff out like we did way earlier. And now we finally have our exclusive right join. So my apologies for a couple twists and turns there. Again, to recap, we're connecting services to car service. And we're doing a right join. And then we're filtering out everything except the results where a car has never been serviced. So we end up over here, right? Because in here, we've got like service was used. And then we only have one or two services here that were never used. So my apologies for the twists and turns. I did want to show the right join. Just to recap, the right join is rarely needed. Most of the time, we are doing simple inner joins. Sometimes we might need a left join like this. But most of the time, what we're doing is stuff like this, where I'm doing a bunch of inner joins together, right? To help me get information that Mike owns a Camry that's gotten a tire rotation. I know I ran a bit long, so my apologies. Let's wrap up. Let me pause the recording, and I can definitely stick around for folks who have questions for a bit. So thank you, folks. I'll send out pairs for the afternoon. I think this will be a good pair coding day. Definitely focus on both querying and joins. The assignments are good. The game one's a good one to build on. We have the behavioral interview practice after lunch, and then there'll be some open work time.